Check, 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 check. Bap. Hey everybody, welcome to the mailbag, the PC Perspective mailbag. It's our last episode of this before 2018 hits, before CES hits. No, we'll have another one before CES hits probably. So if you have CES questions, this is your chance to bring those forth. Leave them in the comments on this YouTube video or leave them in the comments on the post on PCPer.com. And or if you just have any thoughts or opinions on what you hope to see or what you think you'll see at CES, let us know. Because we'll be out there and doing a bunch of coverage, apparently, I guess. That's kind of how it works. But let's get into our questions for this week. Trolling for Dollars wants to know, other than physical size, what are the advantages of moving to a smaller process node? So this is, moving from 130 nanometer technology way back in the day to 20 nanometer to 14, to 10 nanometer. The physical size is obviously a big a part of this, right? Because it allows you to put, or allows production facilities to put more chips on the same size wafer, essentially. More chips of the same complexity, you would say, on the same size wafer, because the wafer size hasn't changed in a very long time. 300 millimeters is where that resides. The other advantages that are possible when you change process nodes are power consumption advantages or frequency switching advantages. So in theory, what we used to see a lot of was frequency switching improvements with process nodes. We could actually switch the transistors quicker and maintain stability throughout the node, throughout the processor, better as the frequency or as the process node went down. That has kind of tailed off a little bit. That's why you see a lot of processor frequencies kind of remaining pretty static throughout. Both in mobile and in desktop, you don't see these huge spikes. Intel's still kind of getting up there once again. 4.5 gigahertz range with their consumer parts, but mobile CPUs have been kind of hovering around the 1.8 to 2.2 gigahertz mark for a very long time. So that's kind of tailing off. And then the power consumption difference is really where we're still seeing some advantages. And obviously that gets you more power efficiency. So not only is that good for mobile SoCs like Qualcomm or Apple or whoever, and obviously for Intel low power stuff, it could also be useful for NVIDIA, right? Or AMD, because now they can build GPUs that are more efficient and they can get more performance per watt, which is, it's important for consumers, but it's way more important for either mobile devices or enterprise data center usage, where you're very much concerned about the power draw and power consumption you have. So those are the primary advantages of process node tech, but size is still definitely an important part of that as well. Kyle Bachman wants to know, why are AMD GPUs better at cryptocurrency mining than NVIDIA? That's kind of an interesting question, right? Because when you look back at the first mining, or the beginning of the most recent mining craze, AMD was the first GPU that flew off shelves, that was sold through and hard to get a hold of. The reason for that is not so much that it was better performance, which it was a little bit, right? So consider this, the AMD GPU tends to be better at things like async compute or general purpose compute. If you think about some specific scenarios, right? The AMD GPUs have been a little bit better at that in terms of consumer GPUs than the GeForce GPUs. But the AMD Radeon cards at the time were in a better performance per dollar and performance per watt space than the NVIDIA cards, right? So performance per watt is more important for cryptocurrency mining, because you're considering, okay, I'm running this card 24 hours a day for a month. How much electricity is that going to cost me? You don't really worry about that when you're gaming. So the AMD advantages were more in those areas than in just kind of raw performance. And you can see that today if you look at the kind of potential profitability of some key cards, right? The Vega 64 is like around $120 per month right now, but a 1080 GTX 1080 is like $136 per month. So it's actually higher than the Vega 64. Those are fairly equivalent parts in terms of gaming performance, and that's fairly equivalent in terms of, your cryptocurrency mining capabilities. So if there was an advantage for performance that AMD had, it's kind of gone away. Now that shifts as well as the algorithms change, as whichever crypto coins are more prominent at the time, that people are more willing to buy the hashing power for, which one has the most transactions occurring. There's a whole bunch of other stuff that goes into that. And it just happens that it started on the AMD side, and they were the first to be really drastically affected, right? So because now you look at the 1080 Ti, it's the highest performer of the standard GeForce cards, beating Vega 64, Vega 64 Water. AMD does have an advantage in that they recognize the value that the crypto miners provide for their market, right? So they have a specific driver that is meant to improve efficiency, meant to improve performance of cryptocurrency mining. NVIDIA has kind of shied away from that, right? And I think part of that decision is they don't want to tick off the gamers, right? Which is something that absolutely has happened in the past. They also don't want to overemphasize mining as a place where they're making profit from, because every quarter, as the cryptocurrency market changes, they would have to admit that, oh, okay, we were planning on going 25% on this, blah, 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 and now it's crashed out on us. So that is kind of where they're at that way. So that's, I would say they're both kind of on equal pairing now. Just a matter of cost for that card, availability of that card, and a lot of other stuff comes into that. Next question from Voodoo. Can overclocking your CPU and RAM degrade the lifespan or otherwise harm your motherboard? So the answer is kind of yes, right? It's something that overclockers don't like to talk about, and it's also a matter of scale, right? So, some very intelligent people once told me that if you run a GeForce GPU at its stock speeds, it'll last 10 years, but if you run it at overclock speeds, it might only last 7. And we obviously don't have the capability to test that. We don't have enough ASICs to run to get even kind of mean time between failure type stuff that NVIDIA or AMD or Intel have. So we kind of depend on those bits of information from these guys when they're being honest and they're talking openly about these types of things. So any overclocking you do is going to degrade the lifespan of your products. That includes your CPU, that includes your RAM, and more or less your motherboard, right? Because when you think about it, you're pushing on a CPU, you're pushing more voltage through it for sustained periods of time. Same thing with memory. For the motherboard, you're pulling more current through the PCIe slot, or you're providing more power to the CPU, and you're putting more emphasis on the MOSFETs or the caps or the power delivery systems, whatever it happens to be. And so you are degrading the life of your product. The argument that you really should be having is how greatly are you degrading the life of your product, and what is the potential lifespan it has for you in your system. I would argue that taking a GPU from a 10-year to a 7-year life cycle is a very reasonable thing to do for the standard consumer who is not concerned about keeping that card more than 3 years, 5 years, whatever happens to be. But I would say, basically when you overclock, you are increasing the chances of anything negative happening. So if your processor was kind of an edge case and it was potentially an early death contender, then overclocking it will increase that. But also, you're kind of, again, you're in that range of, would it increase it? Would it bring it down to a year? Would it bring it down to 3 years, 5 years? It really depends. And I don't really have any good statistics for you on that. Only people that do that are the ones who are producing the silicon and selling it to you. And they really don't want you to know the specific details, because then there's a whole bunch of questions on warranty and availability and lawsuits and all that kind of stuff. So the easy answer is, excuse me, yes, it will degrade the lifespan, but I don't think it's enough for you to bother worrying about it, unless you get into crazy crap like LN2 and volt modding your card and stuff like that, where you may physically damage as opposed to degrade the products that you're worried about. Antonio Cunningham wants to know, what causes laptop CPUs to die faster than their desktop counterparts? I bought my laptop the same year as my Core i7-920. The desktop CPU is still going strong, but my laptop CPU no longer works. I would say that there's no inherent reason laptop CPUs would die faster than desktop CPUs. The only kind of caveat you might have to that is, in general, systems that are running in small form factors like laptops or small form factor PCs like Nanos, Nooks and stuff, would inherently be operating at higher ambient temperatures for longer, which kind of goes back to that previous question about how do you degrade the lifespan of your CPU. I see Jim did a very good job organizing these questions in that order. So if you're running them hotter, they will degrade faster, but there's no inherent reason why that would be the case. And again, the expectation is that Intel is speccing out clock speeds and voltages and all that type of stuff in a way to reasonably predict the lifespan of these products, and probably they're within the range of laptop and desktop counterparts. Chances are you just had like a one-off issue. Sometimes products go bad, but I don't think that's inherently indicative of a notebook form factor artificially decreasing lifespans of silicon for any other reason. So Stalin Vlad wants to know, do you think that the recent drop in Bitcoin price is related to the FCC's net neutrality ruling? I don't think so. I think the real answer is nobody really knows what the hell happens to Bitcoin pricing. Depending on when you sent this question in, I think I saw it as low as like $11,000, but then I saw it at like $19,500. Now it's at like $14,000. I don't think the FCC ruling has much to do with that. I think, you're not using much bandwidth when you're doing cryptocurrency mining. You're using very, very little of it. It's more compute intense than anything else. Pay attention to things like South Korea saying that they might turn off exchanges support in their country. That would be a reason why cryptocurrency value might fall, or people finally understanding that none of it means anything might be a reason that value might fall. But there's too many variables for me to attempt to guess, and I would caution you as well, or anybody watching or listening, to try to predict with any great interest or any great value behind it what will happen. So DBS7 wants to know, during podcast 480, you seem to refer to FP16 and FP32 shaders separately. I thought these were all the same FP32 silicon, and then when you did FP16 math, it either wasted the extra precision or double packed the math for 2 operations per cycle. Do I have the right idea? Actually, yes, you do. If we made it seem like that these were 2 different things, in general, it is not. And I say in general because on the Titan V, they kind of are 2 separate things, right? So the FP32, the single precision shaders on the Titan V, can run FP16 code and math, but they do it at the same rate as they would FP32. So you're losing, you're wasting the extra precision, if you will. However, the NVIDIA part does use the tensor cores for general purpose FP16 math, not just tensor specific math. They can use it for just FP16 math for machine learning and compute models that utilize it. Now it has to be coded for it. The driver is coded for it. That's why NVIDIA builds these containers for their machine learning workloads, right? So that they can help set that up and make it easier for people to use. So in that case, there is a difference between the physical silicon running the FP16 code and the physical silicon running the FP32 code. Now, on AMD's parts, they're the ones that have the, quote, double packed math, which is the ability to run twice as many FP16 operations over the same hardware structure as being able to run FP32 operations. We haven't really seen that enabled in a whole bunch of stuff yet. There are a couple of games. I think the new Wolfenstein 2 actually has some FP16 shaders built into it that you can turn on, and I think you can turn on and off, or at least AMD showed some instances where you could turn it on and off and see some portion of performance improvement. We haven't seen that in our testing in the machine learning side of stuff yet, so we're still kind of working with them to try to figure out why we're not seeing that, or what kind of software environments we need to be in to really support it. But you're on the right. You had the right idea, so I hope that clarified a little bit. Gregor Mima asks, HDR, what's the status for the PC industry? Will this CES finally see the release of more HDR compatible monitors, graphics cards, etc.? First, I would say the graphics cards have support for HDR. That's not an issue today. The monitors is an issue, and 2017 did not even come close to solving it. I think we had two HDR monitors come through here, and they're both very disappointing in terms of quality and actual like peak brightness. The TV market, the high definition displays market in that world have done a very good job, right? We have several HDR TVs here. They work. They're amazing, but they're a very different class of product than what we're used to seeing. Also, keep in mind that AMD has been touting FreeSync 2 support, which includes HDR, variable refresh, and NVIDIA is talking about G-Sync HDR, which is HDR displays, pre-qualed, high quality. They showed it last year CES. We saw jack-all from both of those come out this year. So I'm hopeful that at this CES we'll see some more of that. But I'm also hesitant to believe that even if I see them next couple of weeks while we're out there in Vegas for CES, that I will be able to buy them anytime soon, right? So that's really the problem we have to. I think we'll be more specific in our questions and kind of grilling people about what is the actual availability of this versus just is this a cool tech showcase for 2019. But we'll have some more. Check the website. I will be sure. I promise you, when I go visit AMD and when I go visit NVIDIA, those will be top questions in the list. Saeed Hassan wants to know, it seems like the move from DDR3 to DDR4 memory didn't provide the same performance improvement that we saw between DDR2 and DDR3. Do you think the jump from DDR4 to 5 will be better? I'm trying to... Rose-tinted glasses are a thing, right? So the DDR2 to DDR3 transition was interesting. You had boards that could support both. I don't think that the DDR3 to 4 memory jump didn't see a performance improvement. I think there's just less applications that are primary system memory speed affected, right? Bandwidth affected. Capacity is improved. So that's obviously going to help a lot of specific applications, rendering and machine learning and all that but I still think there's significant bandwidth improvements. Now, every time you improve bandwidth on DDR, you kind of reduce increase your latency. So you make it less performant on the latency side. The move from DDR4 to 5, I don't really know what that's going to look like at this point. I still think that there's some headroom from DDR4 to make some interesting performance improvements. The one place where we saw DDR4 speed affect performance was on the Ryzen platforms, Threadripper platforms, where suddenly memory speed was tied to their internal bus and performance in a lot of different areas, even gaming, right? Something that we haven't seen in a very long time. Seeing these improvements past 2133 to 2400, 2666, 3000, 3400 megahertz DDR4, we've seen improvements and what it can do for the Ryzen platform there. So I still think there's a little bit of headroom left to go. I honestly don't know what to expect from DDR5 other than, higher frequencies and higher bandwidth. But the question will be what applications are actually going to utilize that. Because I think that's probably what slowed down more than the improvement in the memory technology itself. There's just more of an emphasis in the memory industry right now on increasing capacity than increasing speed, right? Because of the data center increases, machine learning, AI, all that stuff, capacity is king right now. Lucian Popescu, sorry if I mispronounced that, wants to know, what do you guys know about Navi's timetable? Do you think we'll see something from AMD at CES? There will not be any Navi stuff at CES for two reasons. One, it's too early, and two, I would almost feel like a political suicide at this point to show Navi and try to talk it up without having a ton of information and a ton of confidence and performance to back it up. Because they cannot start down the same road they did with Vega, with Navi. They can't market it and talk about it being the second coming and how it's going to destroy Volta and all these types of things, knowing that what occurred with Vega, right? They can't do that again. They need to take AMD needs to be more intelligent this time around and take the under promise over deliver as opposed to the over promise under deliver mentality of things. Obviously, they didn't want to over promise under deliver, but that's what happened, right? And that's the risk you take. The risk of under promising is that you cost yourself a little bit of excitement and interest in the market. But I think the risk of overpromising is much more significant than that. So I don't think we see anything about Navi from CES. It's at least a summer fall 2018 part, if not after that, right? You got to think there's been a lot of transitions there with Raja leaving and Lisa taking over. There's no new helm at the GPU division right now. And so there's a lot of question marks about what's happening inside that product roadmap. So we might get some answers on that. We might get some timetable answers at CES, but I would not expect any product answers or information. All right. I like Waluigi asks, why do you not use your standard set for the mailbag episodes? The mailbag background can be distracting. Where's he at? There he is. With the inconsistent lighting, frequent Ken and Alex walkthroughs, and random boxes scattered about. The background is like a colonoscopy at the PCPer office. I would challenge you that it's not even the worst view of the office. It's probably one of the nicer views of the office in terms of cleanliness and organization. Wait, we got some more distractions coming in.
Now it's the worst view.
Now it's the worst view. We record this here because it's easy and it's convenient. I can record it by myself at this computer. Jim set up this microphone for me so I can just literally pull it down from the monitor, record, send a file away, and be done. And I actually think it's interesting for you guys to see some of the other office spaces, not just the clean, uncluttered look of the set that we see. You know, like last week you got to see Ken burning people at the stake in The Witcher 3 while he was benchmarking the 1080 Ti Strix card from Asus. You get to see some of our cable management skills and capability. You get to see like the posters and artwork that I own lean against the wall for months on ending, right? So I think that's a shine. And if anything, maybe we'll give you more angles, right? And now you've got to see Josh's place again. You get to see Alan's place again and the wall of crap that he has behind him. I find it more interesting. So hope you can learn to appreciate it a little bit too. I like Waluigi. All right, that's it for this episode, guys. Thanks for joining us. We'll have another episode next week before CES, the first one of 2018. And if you have CES-specific questions, there was a couple of them in here, but feel free to send more. Again, leave them in the comments on YouTube or on PCPer.com, and we'll probably find them, and maybe we'll answer your question as well. So thank you, guys. We will see you next year. Bye.